Alright, what's this lesson going to be about?
Multiplying mixed numbers.
Multiplying mixed numbers.
Get the door.
Okay, with this lesson, you guys are going to use a skill that we've already learned, changing a mixed number to an improper fraction. Who said that? Okay, so if I give you, what's this mixed number?
2 and 3/4.
2 and 3/4. Let's change this to an improper fraction. You know how?
11.
Hear it?
You do 4 times 2.
4 times 2 is 8.
Then 8 plus 3 is 11. And you keep the same
11.
denominator.
And you keep the same denominator. So, I went from 2 and 3/4 is the same thing as saying 11/4. This is just the proper way to write it. This is an improper fraction. Review? Feel pretty confident about doing that?
Yeah, I feel pretty confident.
Okay, because you're going to need it.
Oh, no one.
So let's use that 2 and 3/4 and multiply it by
I'll use it.
a whole number.
You don't know
We know what to do with whole numbers, right?
that. Nope.
What do we do when we multiply by a whole number? Brody? You don't have to get the same denominator. When you have a whole number,
1/8.
oh, what do we do? I just changed this to make my denominator 1. Because 8 divided by 8 is 1. So let's change this 2 and 3/4, which we've already done. What is it as an improper fraction? 2 easy steps. I changed this to this, and I changed 8 to 8/1. 2 steps, that's it. And you guys already know how to multiply fractions. So let's just do this the regular way. 8 times 11, fraction bar, 4 times 1. Okay, so let's take 88, divided by 4. 4 goes into 8.
Did you do the trick?
2 times.
Did you do the trick?
So what's my answer? 22. That's my answer. Absolutely. Let's do the trick real quick.
Are you always going to get a whole just a whole number for your answer?
So, 1 and 11. I'm looking diagonally. Can they reduce? No. 1 and 11. It's already there. What about 4 and 8?
Yes. 4 goes in 4 one time, and then 4 goes in 8
2 times. So now, do I multiply diagonally?
No.
No. How do I multiply?
Just like you would.
Left to right. So, 11 times 2 over. And what's 22 over 2? I mean 22 over 1? Just plain old 22. Because 22 divided by 1 equals. Is that pretty simple?
I need some intermediate.
Alright, now you've multiplied one mixed number by a whole number. Let's multiply 2 mixed numbers. I'm going to just say darn it. 4 and 2/3 times 2 and 1/4. What's the first step I have to do? Ben? What do I have to do when I have mixed numbers? I have to change them. Improper fraction. So I'm taking my mixed number here, 4 and 2/3. I'm going to change it to an improper fraction. And 4 and 2/3 would change to
14 over 3.
3 times 4 is plus my 2. So 14 over 3. Bring that down. Still multiplying. Let's change 2 and 1 4.
9 over 4.
4 times 2 equals
8 plus 1.
plus my 1 equals 9. My denominator remains the same. So I now have 9 over 4. Now I'm going to write this twice for those that want to see how to simplify on the way. And we're going to do the regular way first though. If we're doing just regular way, Jeffrey, what do we do? Just regular old multiplying. 3 times 4 equals 14 times 9. Gotta do that to the side. 4 times 9. 9 times 1. Plus 3. Can I reduce this?
Yes. 10 in 12 or 1/10.
Let's divide them both by 2. 12 divided by 2 equals, let's divide 126 divided by 2. 2 goes into 12. 2 goes into 6. 63 over 6. What should I do? Does 6 go into 63 evenly? So let's just divide. 6 goes into 6. So what's this now? My remainder 3, but if I want to make that a mixed number, it becomes my numerator. Good job. So 3, what's my denominator?
6.
So bring that over here so you guys can see it. I now have 1 and 3, 6. Simplify to 1 and 1 half. So JT, does that answer your question? Is it always going to be a whole number? No. Okay. Let's just do it with the quick way first. What 2 numbers should I look at? 3 and 9. Can they reduce? To what?
3.
3 goes into itself.
1.
3 goes into 9.
3 times.
What about 4 and 14?
Nope.
No, 4 can't go into 14. However, I can still reduce these 2 numbers. By 2. Good job, Garrett. Because 2 goes into 4 how many times?
2.
2 goes into 4 2 times. 2 goes into 14.
7 times.
Now I have 7 times 3. 1 times 2. Now I have 21 over 2. Do you guys notice that most of the time that we've been reducing, it just so happens that they'll go into themselves? Like 3 goes into itself 1 time, 3 goes into 9 3 times.
Yeah.
But this time, 4 didn't actually go into 14. However, they did have a factor in common, and that factor that they had in common was 2.
What if they don't have that?
If they don't have a factor in common, then they can't,
Then you can't do the
then you can't reduce them. Okay? So no, we're not done. We have to take 21 divided by 2. You got 1 left, so 1 and 1 half.
10 and 10.
Oh. What?
How'd you get 1? That's why I had 2 and half 2.
Oh, I'm sorry.
It takes you 10 to get to 20. 2 times
I was looking at you just going into 2. Goes in 1 time. So then this would be 20. No. I gotta redo this up top. Right, so it's 0. I gotta make more room for this. So this would go in 1.
You didn't bring down the 1.
Oh, I didn't bring down the 1.
You have to put a 0 up there because you just brought them.
No, this would be 1 and 1/2.
Yeah, it'd be 1 and 1/2.
Oh, 10.
Yeah, it'd be 1 and 1. Because 2 and 1/2.
It would be 10 and 1/2. You're right.
You would make it go into 1.
Because you can't go into
20.
Oh.
Oh, you're saying 2 goes into 21 10 times would mean would make it 20. 2 times 10 equals 20 with a remainder of 1.
That's what I do it. And I use my remainder, and then I use my denominator for denominator, but my remainder goes on top of the numerator.
Yeah, and 1/2 would still be our remainder, but that doesn't make this one right.
That's because you put 6. That's because when you had 3, you didn't put a 0 before the 3. Because 6 has to be.
Oh, thank you, Derek. Okay. He's saying if you look back at this one, we never put 0 right here. So it should be 10 and 1/2 because, okay, Derek, I see what you're saying. We only have 1 here in the 1 spot, or in the 10 spot, but we didn't have anything in the 1 spot. Does that make sense, you guys? Because when we were dividing 63 by 6, we said 6 goes into 6 one time, and we just finished it out making this 3 6. However, we weren't looking at. I'm sorry. Yes, we will look at this one more time.
Yeah, can we do a different problem?
You just want to do a different problem.
This
Hey,
is
this one we can
simple
do
for the
on
other
our
kids around here.
Derek. All right, we'll just do a different one.
Yeah, let's do one for Derek.
On our desk.
The younger kids.
So you have 2 and 1/6 and 4 and 1/2. What do you have to do first?
6 times 5.
You have to change them to improper fractions. 6 times 2 is 12, plus 1 is 13 over 6.
9.
2 times 4 is 8, plus 1 would be 9 over 2.
No, multiply. It would be 12.
Do it on your board, Carson.
This won't work. This one doesn't work for the
This one works for the trick.
You said it had a U.
So, I had to check my work real quick. I just had to check my work real quick. I just had to check my work real quick. We can reduce this. Why? 2 doesn't go into 13. They don't have a common factor, do they? No. But do 6 and 9 have a common factor?
Yes.
3. So you could say, does 3 go into 6? Yeah. 2. Does 3 go into 9? That's the trick. No, you don't have to do both diagonals to do the trick.
You can have 1 and do it.
Yeah, like the time we did in our homework where it was only 1 and 15 can't reduce, can they? No, so that one diagonal didn't work, but the other one did. You don't have to have both diagonals always reducing.
Can we do,
So